So let me introduce you now to a concept called arrays in C. And they are basically big lists of data, if you will. Data in consecutive memory locations. So an array is an assortment of data of identical data type. The data type itself could be a standard data type or a compound data type. However, it has to be identical data types. There is no limit to the size of an array as far as C is concerned. However, physical limitations of the system in which your code executes, of course, apply. So in your desktop computer, you can probably have quite large arrays, but if you were programming an embedded system, which is what C is typically used for, then that would be a completely different case. Now, elements in arrays are sorted in consecutive memory locations, as we've said in the introduction. And array size is non-dynamic. It is set once during the declaration of the array, and it is fixed from that point onwards. You cannot sort of add elements to the array and remove elements from the array and these kind of things. Now, it is not possible to add it's not possible to add extra elements or remove them, as I said. A one-dimensional array is like a list. It's also referred to as a buffer or a vector. You might have heard it referred to as any of those two things, depending on implementation. And this is how you go about declaring an array of characters with size 12, so an array of 12 characters. And that's what it would look like in memory if you were to write hello world in it. So its space here gets its own character. Yeah. Now array elements have a memory address in which they live, just like everything else, and they are basically one character per array element, as you can see here. They have a data type identical to all elements, and they also have an index which starts at 0. So element 0, the first element is element 0, the last element is element 11, and this array goes from 0 to 11, which is 12 different elements as part of the array. Now, I don't really know how to best describe this, but this is basically what everyone always gets wrong. So C programmers like to start counting from 0, because that's where arrays start. And they go up to n minus 1, n being 12, minus 1 being 11, yeah? So basically from 0 to 11, you have 12 elements. The first element has index 0. Everyone makes this mistake, or almost everyone makes this mistake, which is a very bad mistake, by the way. They create arrays and they think that they start from 1. So it does need a little bit of getting used to if you want to be able to work with arrays. I highly recommend you can work with arrays, and this is the mistake that everyone does. Almost without failure, everyone does it. This is how you would go about initializing this array so that it has the hello world in here, as you can see it. So A0, this is a reference of the element of the array, equals to, and then I've put the character hates, ELLO, and then I have some empty space here, and then world. As you can see, I go from A0 to A11. There is no A12. A12 does not exist. Okay, from 0 to 11, these are 12 elements in total if you count them. Right, so this is how you go about creating it on your computer effectively. So A12, as you can see here, so this is the declaration of the array, and then what you may want to do is you say, okay, you want to actually initialize it, and you would do something like this to initialize it. So you write hello world like this. There are many other ways of initializing arrays, but this is the one I'm showing you for now. So Yeah, making it look really nice. So hello world, as you can see here. So now I've put in the first element of the array with index 0, I've put the letter H. In the second element of the array with the index 1, I've put the letter E, and so on. Now if I really wanted to print the first element of the array, then how I do that? So print f, and then I would say \n, you know, give it a new line, make the world a beautiful place, array element 0, and then we say okay, %c, because we want to print it as a character, because we put a character inside. And then here we're gonna say okay, the first element of the array, and this is how you actually go about saying the first element of the array, a0. That's the first element of the array. So if I was to print that, I get array element 0h. This is what I've put in there, so life is good. Now what you may want to do is you may want to write the rest of the statements to print hello world, or read all the memory locations. So I've just copied everything. You may want to pause the video and do that. And basically that's what you end up having here. So if I was to run this, you will see it looks really nice. It looks like this. Okay, so it printed everything. Everything is in order. Everything is what we expected it to be. Now, interestingly enough, as I've mentioned, array elements also have memory locations in which they live in. Okay, so I've put here a memory location. The memory locations usually in C are expressed in hexadecimal. However, as you have seen, you can actually translate hexadecimal to a decimal and so on. But typically C programmers express them in hexadecimal. So what I've done here is I've put some memory addresses. Now if I go to my code and run it, actually if I wanted to interrogate my code about what the memory address of each one of those memory locations looks like, this is how I would go about doing it. So first of all, let's get a nice printf statement and get myself a couple of new lines so the code looks good, and then get another printf statement, and we'll say here, for example, array element 0 in the first instance. Here we go, array element 0, and then we will say okay, what is inside it, and then let's say lives in 0x 0% yes, 0x %x, excuse me. And then we're gonna say okay, first we want to say whatever the element was, normal stuff, yeah, just as we did before. And the second one is gonna be it's gonna be printed in hexadecimal, and what we really want is we want the address of that element. So we want the address of A0, and that's gonna give us the place in memory where A0 lives, and that's gonna print it nicely in hexadecimal, because it's gonna take the hexadecimal number, whatever it is, and it's gonna put a 0x in front of it, which is the standard prefix for knowing that you're reading a hexadecimal number. If I was to run this piece of code here, it will actually tell me now that H, so array element 0 lives in this location, 0x60FEF4. So if I'm right, they live in consecutive memory locations. So if the first one is 60FEF4, then the next one is going to be FEF5. because if you add 1 to FEF4, the next memory location directly after that is FEF5, effectively. And well, we know that the char only takes bits, eight bits, which is 1 byte, and every byte in memory can be addressed individually. Therefore, I am just going 1 byte later, effectively here. So FEF4 and FEF5, they have 1 byte difference in memory. This is just the next byte. This is just the next location in memory, which can store up to 1 byte, up to 8 bits. And actually, what I want to do, in order to prove what I just said, is you change that to a 1 so it looks good, and you change those to a 1 as well. And then you go about running it. And that's what comes out. So FEF4, FEF5. So we have now proven that they live in consecutive memory locations. And just so that it is nice and complete, I'm going to go ahead and put the rest ones of those here, so that we can print them and see the complete picture. So 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So yeah, this is where these things live in memory. So as we said, arrays live in memory, like array elements live in consecutive memory locations. Okay, so yeah, that's basically it for now. Let's see now though. What if we had something different? What if we had, for example, integers? So instead of char, what if it was an int? And then instead of these elements, we said, okay, put the number 1 in here, the number 2 lives here, the number 3 lives here, and so on. So I've pasted all of those here, and then instead of %c, let's say we want it as %d. So I'm gonna change all of those as well. Now my question to you as I'm changing those is, will I still see a 1 byte difference when I read the memory addresses of those things, or will I see something slightly different? Maybe, for example, because an integer takes more memory space than a character, perhaps my result will be slightly different in terms of the memory locations where these things live. Let's have a look, shall we? So here you can see my array elements are printing nicely, 1, 2, 3, 4, 5, 6, blah, 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 all the way up to 12. Yeah. And now here you can see something quite interesting. Okay, so array element 0, which contains 1, lives in location D0 at the end. The next one is D4, the next one is D8, the next one is DC, the next one is E0. So actually what you can see here is we have 4 memory locations taken for every single array element. Now each memory location can contain a byte, so that tells us that for some reason we're taking 4 bytes. Well, it turns out that 4 bytes are 32 bits, which is the exact number of bits that an integer takes. An integer in our system takes 32 bits. So this will use basically 4 memory locations worth of 1 byte to store the first element of the array, and then the next element in the array will go to the next available space in memory, which is this address here. And of course, because each one of those elements takes 4 memory location, takes 4 bytes, we're skipping 4 memory addresses every time we go down this list. And that's basically why this thing works. This is how this thing works effectively. As you can see, all thing I did here in the code really is I've just changed things to %d. The rest of the code is exactly the same. Yeah? Alright. Let's have a look at some other properties of arrays. One of the things that you may find useful with arrays is the ability to initialize an array during declaration, and the way you do this is as such. So basically you put an equal sign here, and then you can start writing things here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and now I've basically initialized my array. Let's make this look beautiful as well, because it's getting to my nerves now. And yeah, so if I try to run this bit of code here, you will see actually it has worked properly. Yeah, and we have actually initialized it. Oh, I forgot to put the last element of the array. You can see actually C didn't complain about it at all. Yeah, it just let me do it, and it actually automatically by itself initialized the last element of the array to be 0. Now, one word of warning: don't expect uninitialized variables to be set to 0. This is just pure luck that it happened this time. Another interesting thing is actually I should be able to remove the size of the array from here. Let's put that 12 back there as well. I should be able to remove the size of the array from here, and basically the compiler is clever enough to just see how many elements I have initialized, and it will create an array of the size of the elements that has been initialized. So in this case I have initialized 12 elements, so it will create an array of 12 elements, which will be 12 integers. And if I try to run it, indeed you will see that it has worked properly. So this is one of the ways in which you can initialize an array really quickly, create and initialize an array really quickly. And basically the size of the array did not dynamically change while the program was running in order to accommodate the number of variables that I wanted to store inside it. What actually happened is that the compiler came here, it saw how many variables we have here, it said, okay, we have 12 variables, so I'm going to effectively turn this array into an array of size 12. So this is quite an interesting thing for you to know in terms of initializing an array. Hello and welcome to the Complete C Programming course. This course will teach you essential C programming skills to enable you to get your first programming job or a promotion. Even in 2020, C is still one of the most popular programming languages, and due to its unique capabilities, it will stay relevant well into the future. Nearly everything we touch today, from our cell phones to remote controls to cars to even the mouse of your computer, is either influenced by, if not directly written, in the C programming language. Traditionally, learning C is very syntax heavy and generally not much fun. However, in this course, things are different. All the concepts are analyzed from multiple perspectives. Comprehensive slides graphically illustrate what happens inside the computer. And finally, fun exercises with multiple examples are used to explain different concepts in depth. This course has been designed with the complete beginners in mind, people that have never programmed before. It will also be useful for experienced programmers that have not worked in the C programming language and they're interested to learn it. Finally, it is also ideal for people who have a basic understanding of C and want to reinforce their programming foundations. With more than 12 hours of video material, 68 plus lectures, over 45 explained code examples, and many fun exercises, this course will teach you how to use the C programming language like a pro. At the end of this course, you'll get a certificate of completion that you can put on your LinkedIn profile to demonstrate your new skills to potential employers. For your benefit, this course is backed up by our 30-day money-back guarantee, so you can try it 100% risk-free. If you don't like it, you get all your money back, no questions asked. Even if you claim your money back, you can keep all the notes from the course. This is our way of saying thank you for giving it a try. So now that you know what this course is all about, enroll, and I will see you inside.